Misalignment of the shafts causes vibration in both machines. This will damage the bearings, seals, coupling, or other machine components. Good shaft alignment allows machines to run more efficiently, reducing power consumption while increasing output. Let's look at how it's done. Very common rotating machines in industry are pump and motor sets. When a motor runs, the shaft rotates and transmits power through the coupling to the pump. Because alignment is so important, tolerances were developed to define the most misalignment you can have and still be okay. We will explain about these tolerances in a future video. If this was a 3600 RPM motor, these would be the tolerances. Forget for a second that we are aligning two machine shafts. Instead, imagine two simple lines that represent the shafts. The goal of an alignment technician is to adjust these two lines to be collinear. Collinear means that two lines are positioned as if they were one single line. In the real world, we aim to align the machines as collinear as possible within tolerance, at the coupling or point of power transmission. Typically, the machines will be misaligned in two ways and in two dimensions. Let's visualize this. Vertical and horizontal. Both vertical and horizontal directions each have a combination of offset and angular misalignment. To measure, we rotate the shafts to find the relative positions between the two center lines of rotation. Once we know the misalignment, we can correct it by adjusting the movable machine vertically and moving it side to side in the horizontal plane. If we get the two rotational center lines to be nearly within tolerances in these two directions or planes, then they will be nearly collinear and therefore properly aligned. The process of precision alignment can be broken down into three simple steps. First, measuring and inputting the machine dimensions. Second, measuring the misalignment between the shaft center lines of rotation.